Hello everyone, Namaskar. So today we are going to solve one more question. It looks a question from triple integral, but to your surprise, I'm going to solve this by Laplace transform because I feel that is easier as far as this question is concerned because uh, because all the three integrals are the same. So what you will do when doing integration normally, you will solve for the inner integral, throw whatever result to the outer one, again solve the outer one, and you will throw the result to the outermost integral. So that might take time, but while solving from Laplace is just a matter of 2 to 3 steps which will give you the answer. So let's start off. So let's see how. And while solving from Laplace transform, we'll start from the rightmost thing. So first of all, I will need Laplace transform of sine 80, which you need for this question. So if you don't know what is Laplace transform of sine 80, that is a divided by s square plus a square. So that is the first thing. I only need two more properties to go, and that's it. So because I'm explaining, it might take more time, but while doing it, just a matter of 1 to 2 minutes. Okay, so sine 80. So first of all, I am finding Laplace of sine 80. Here a is 1, so simply 1 divided by s square plus 1 square. So 1 divided by s square plus 1. What's next? So if you say that Laplace of f of t comes out to be somewhat f bar s, and you want to calculate Laplace of t multiplied by f of t, and you don't want to use definition, you say, because I have already done some hard work in obtaining the Laplace transform f of t, why to do that work again? So I will say you don't need to repeat your definition work, just do one thing with whatever power of t. So if I want to say the general formula, let's discuss general formula also, so that it becomes even more clearer to you. So if you are multiplying by t power n, it's a general thing of f of t, then taking the Laplace transform. So what you say, that first of all multiply by minus 1 power n, and whatever is the power, take that order derivative. So power is n, so take nth order derivative with respect to s of the Laplace transform f of t, which I told you is f bar s. Okay, so if you want to write for the first, so Laplace of only power 1, so that's simple. Minus 1 power n is just a minus sign, and d by ds of f bar s. Let's do that. So Laplace transform of t times f of t. So t power 1 times sine t will be nothing but minus d by ds of f bar s. F bar s is nothing but whatever Laplace transform you have obtained for sine t, which you are multiplying by t. So that I obtained is 1 upon s square plus 1. So how you differentiate that? I can write this as minus d by ds of s square plus 1 power minus 1, and then I will apply the power rule. So I hope you know the power rule. I am going from the basics. So d by dx of x power n is nothing but n comes at front, x power n minus 1. So minus 1 will come at front, that will cancel that minus sign. You will be left with d by ds of minus 1 comes at front, and in the same step you have to decrease this power by 1. So s square plus 1 power minus 2, and then you will apply the chain rule which says you have done the derivative of power, do the derivative for this s square plus 1. So derivative of s square will give you 2s, derivative of 1 will give you 0. So you have obtained this. Fine. So if I want to write Laplace of t sine t in a better way, so that I have obtained to be, if I want to write it in a better way, I will write this as 2s divided by s square plus 1 whole square. Now comes the real work. You have to integrate 3 times. Okay. So integral is very easy as and when it comes to Laplace transform, because if you are finding integral from 0 to t of f of t and then taking the Laplace transform, then it's easy, because Laplace transform of f of t, I told you, that is f bar s. Just divide that by s. If you are integrating it once, just divide by s. Now again, if you want to integrate, divide by s square. So if you are integrating it twice, divide by s square. If you are integrating it thrice, divide by s square. S cube, sorry. Okay. So depending on the number of times you integrate, here dt will also come. Depending on number of times you integrate, that number of times will come in the power of s. So here, because as you can see, we have to integrate it thrice from 0 to t. So you all know that Laplace transform of, you are integrating it once from 0 to t, twice from 0 to t, and thrice from 0 to t. So dt will also come thrice. So this, as I told you, if you are integrating it thrice, divide by 3 powers of s. Okay. So divide by s 3 times. So whatever we got, the Laplace transform of t sine t, which is 2s divided by s square plus 1, write that. This divide by s cube. So just divide by s cube. Look how simple integral was there. Just we have to divide by s cube. So now this becomes 2, and the final result which we are getting is 2 divided by s square plus 1 whole square into s square. Look how simple it is. Okay. So that's it. That's why I chose this path rather than going for the integration. We should be familiar with both, so that whichever way it is required we can solve. So first step, find Laplace of sine t, then multiplication by t property which says minus sign and differentiate with respect to s of f bar s. Then comes 0 to t integral, which is how many times you integrate. This was 3 times, so divide by s. That's it. That's how simple it is. Do watch my playlist on Laplace transform where I covered similar problems. Do challenge your friend by sending one of those questions. Let's see how he reacts to this question. Do subscribe to my channel as well. Thanks and have a nice day.